Hey guys, wanted to do a quick little demo here of this particular dev board that I'm working with. This is known as the Smart TV Android Player. It is based on an AmLogic 8726 chip, system on a chip, which contains a Cortex A9 core, a Mali 400 GPU, and a video coprocessor made by AmLogic. To basically become, in this particular form factor, it's meant to be a bit of a set-top box, which, as you see here, we've got power indicator, IR indicator, and our little Android logo here. But don't let it fool you, since this is an Android box, it does run Linux, and AmLogic actually does provide a build root for Linux that you can build using build root, or using their root file system to get the driver support for everything that you need, including the GPU, including the video coprocessor, and everything else. On the back, not all that much to write home about, but very basic set of connectors. You have HDMI, left and right audio, as well as coax digital out, Ethernet, and power. The other connector right here is for YB, is for component. So you pretty much have everything you need to be a set-top box of basic sorts for media playback and whatnot. There are other variations of this box that have DVB tuners built in and whatnot. You can get this guy for about 150 bucks from most Chinese distributors, and it has a very nice footprint. Now, for the purpose of the demonstration here, I have used the standard Android update mechanism here to basically flash the device, and it has a small script on it that basically wipes the system root out and replaces it so that it will boot off of the flash device here, so I can do development work for my client. Now, I'm going to go ahead, put my display back on here, and we've connected it back up. Now, I'm going to go ahead just to show that even though this is an Android type device, we can go ahead and I will press these two buttons right here, starting with this one right here, which is the update button, and the other one right here, which is the reset button. And that will cause this to happen. It restarts, I hold it down for a few seconds, let go of the reset, and the system will launch the update mechanism. As you can see right here, bam, no problem. Oh, sorry, I actually need to put that back in. But it can be, you can use this mechanism to basically flash the device. With that in place, I'll go ahead and reset the device. We come back up, and as we start noticing, it will take and automatically start booting from the flash tick. Now, of note here, currently by default with the root file system here, there is no frame buffer console, so it won't put anything up here unless you explicitly put something up here. So we'll go ahead and go to my development laptop here. And we will connect to the device. Currently it has BusyBox on it. No password, I just telnet it directly to the device. If we run a uname, we see the basic string. It's an ARM v7L, of course, because it's a Cortex A9. Pretty basic system here. And pretty basic complement of devices. And the D message is pretty standard as well. You'll see bits and pieces about the Mali device, etc. You'll notice that it's all there and all properly initialized. And the TV mode right now is currently set to 720p. Now, I'm going to go ahead as a test And I'm going to spit some random stuff to the frame buffer just to show you that it works. Basic frame buffer writes to the bus work just fine. And as a final demonstration here, I'll show you that the GPU actually works by running one of the clutter demonstrations. This is test Cairo flowers. Takes a moment, flashes and initializes the display, sets up the display parameters, and once it's ready, there we go. See? Cool, huh? So, yeah, there we go. As you can see, nice support for the underlying display and actual OpenGL support. So, until next time, guys, I'm actually going to take and do some work on the codec that I'm doing for the client. I'll do a little demonstration here so you can see the video output possibilities from this device as well. So far, I'm impressed. It's an ARM-based device, and as you can see here, we've got a lot of different splines going on here, which is slowing down the GPU a bit, but as you can see, as more stuff gets off the screen, you'll see it speed up to full speed here. So we have to be very careful about how much stuff we put on the display here, especially for these on-screen displays. So, yeah, I'll go ahead and stop it here. And you'll notice as we stop it here, since this is running on the basic frame buffer context, it just stops what it's doing right here. We do have a number of other system display classes and things that we can talk to in the sys class folder. And as you can see here, we have a lot of kernel support for various bits and pieces of I2C, the audio codecs, the different display systems, and everything else, that we can talk to everything. And like, for example, I can go to graphics here. And we see the two frame buffers. Yes, there are two frame buffers, and they're laid on top of each other. FB0 is the primary frame buffer used for the 3D. FB1 is the video plane. And we can go ahead and go to FB0 here. And you can set all sorts of parameters in here, as you can see. But for now, I'm just going to go ahead and blank the screen. Pressing enter, and the screen's blanked. So, yeah, there we go. Until next time, guys, more to come, but I just thought I'd take and show this off real quick, because I think this would be a good candidate for a Linux MCE set-top box, because it's actually got driver support. Holy shit! Alright, guys, talk to you later. Bye.